We are live right now. I hope I'm audible to all of you. All right. We're live right now. Yeah. So, welcome back to this platform of Tutee Learning, JEE. So, today, let's gonna discuss about the differential equation, right? So, as of the last lecture that I took previously was on solution of differential equations, especially variable separable type and homogeneous differential equation, right? So in today's session, we are going to discuss about solving the most important part or set of differential equation, that is the first order linear differential equation, right? So let us start to understand how we are going to solve the solution of a linear differential equation of first order. And along with that, we are also going to discuss about the Bernoulli's equation, and at the end, we are also going to talk about a bit on orthogonal trajectory, right? But before we start with the class, now in the previous session, if you have watched the previous session, I have already asked you to solve a homo problem, right? So if you haven't watched the previous session, I would request all of you to please go back to the channel playlist, and from there please watch the previous lecture before we start to solve this today's class, okay? So this is a question. Please try to solve the question, and before we start, try to proceed with the class. All right, so this is a very simple problem, and this is a very simple problem from the homogeneous type of differential equation, right? But looking at the problem, it might be a question to all of you, that this question might look like it is a second degree differential equation, right? Yes, it is a second degree differential equation in the following form, but in order to solve this form, you have to first try to bring it in the form of a first degree differential equation, right? And then you have to solve for each of the individual differential equation, right? So I leave this question up to you to solve, and we'll discuss the solution of this question in the later stages, right, or later classes. Before that, let us try to understand how to solve a linear differential equation, right? So today, our scope of understanding this particular session is basically to solving the most important part of differential equation, that is a linear differential equation. Okay, a linear differential equations. Okay, so let us see how to solve linear differential equation. Now please note that we are only going to solve linear differential equation of order 1 and degree 1. Alright, so we are only going to focus our attention is to solving linear differential equation of first order and first degree, right? So let us try to see how does first of all, let us first of all look into the matter, that how does a first order differential equation looks like. Oh, sorry, first order linear differential equation. Okay, so so let us first of all understand how does a first order linear differential equation looks like, right? And why do we use the word linear to such differential equation? We'll try to understand that in detail. Okay, so let's try to see how does the first order linear differential equation looks like, right? So if I talk about a first order linear differential equation, and before that, if I talk about the word linear, right? So what do we actually mean by this particular thing over here? What is the actual meaning of a linear differential equation? Let's try to focus our attention into this particular thing, right? So what do we actually mean by a linear differential equation, right? So a differential equation is said to be linear. A differential equation is said to be linear if an unknown variable and its derivative. So if my y is my unknown variable, if my, so since the degree order is 1, so there will be only one variable, right? So if my variable, unknown variable and its derivative, okay, if my variable and its derivative with respect to the independent variable, so this is the derivative term, right, occurs only in their first degree, right? So both y as well as dy by dx occur in its first degree, right? So if both the unknown variable and its derivative occurs in the first degree, then only this kind of differential equation are known as linear differential equation, right? So a general linear differential equation actually looks like this. So if I have the derivative term plus some function of x multiplied with y equals to some function of x, right? Like this form, then only I call such form of differential equation as a linear differential equation of first order and first degree. So what you can see that the variable, that is y, and this derivative term occurred in its first degree, and such differential equation over here is basically a linear differential equation. So this form of differential equation, so any equation of the form like this, so an equation of the form, okay, of this particular form, dy by dx plus px multiplied with y is equal to q of x, such form of differential equation is basically known as a linear differential equation of first order and first degree, right? And please note that this px and qx are functions of x or maybe a constant, right? So you have to understand, and these are also, then this particular equation are known as a linear equation of first order, right? Now, how do we actually go to proceed to solve these types of question, right? That is the most important part to understand. Now, whenever you see these kinds of differential equation, how are you going to proceed with the solution of differential equation? That is what we are going to learn now, right? So, in order to proceed with the solution, so let's try to understand how am I going to solve these kinds of differential equation, right? So in order to solve this differential equation or to get the general solution of the above equation, we need to proceed by follows, right? So there is something called as integrating factor, right? There is something called as an integrating factor. So what you will see that if I multiply both the sides, by e to the power px dx, so e to the power integration of px dx, I should write like this, that e to the power integration of px dx, if I multiply both the sides by this particular quantity, okay, let us see what is this quantity and how is it going to help us in solving the questions, right? So if I multiply both the side of this differential equation with e to the power integration of px dx, what I'm going to get over here? I'm going to get, so if I multiply with this, that is e to the power integration of px dx and dy upon dx plus y times of p over here into e to the power integration of px dx is equals to q of x into e to the power integration of px dx, right? Like this over here. I hope this is clear, right? Now, once we understand this, now once we multiply and multiply both this side by this, now in order to proceed with the solution, what I'm going to do is that let's try to understand how am I writing these things, right? So if I consider this was one part of the derivative and this is another part of the derivative, what I can do over here is that I can club this part. So this part I can write it as y times derivative of e to the power px dx, like this, right? If you can follow over here, if I consider y into e to the power px integration px dx as one function, then when I differentiate it by using the product rule, then with respect keeping e to the power integration px dx as constant, I will differentiate y, and that is written over here as the first part. And then if I differentiate to keeping y as constant, then this is my second part, right? So that I'm trying to write over here, right? So this is what I'm trying to explain over here, that this will be like this, and this is equals to q into e to the power integration of p dx, right? I hope this is clear. So this particular term over here cumulatively add up to basically give me the term that is derivative of y into e to the power integration of px dx, and that is basically equals to q into integration e to the power integration of px dx, right? Over here like this as follows, right? Now once I obtain this form over here, then if I integrate both this side, so then I can do the variable separable thing over here. So this is the derivative term, and I can take the dx over here, and then if I integrate both this side to get to the solution, so my solution or the general solution will look like, so my general solution is now going to look like this, y into e to the power p integration px dx is equal to integration of q into e to the power integration p dx and dx of this, right? So this is going to be the general solution of such differential equation of first order linear differential equation, right? So this is going to be the solution of the first order linear differential equation, right? I hope this is clear to all of you. So this is going to be the solution of a or general solution of a first order linear differential equation, right? So this is how the general solution of a first order linear differential equation is going to look like. I hope this is clear to all of you. And therefore, if we understand that by multiplying with this particular term, so by multiplying with this particular term, it is basically getting easy, right? So this kind of term is basically called as the integrating factor, right? So this is a factor which helps the derivative term to be integrated, right? So that's why we call this particular term as integrating factor, or we write it as I dot f, right? Integrating factor. So the general solution can be given as, the general solution over here, it is y into integrating factor is equals to integration of q into integrating factor into dx, right? So this is my general solution. Okay, so this is how the general solution is going to look like. This is how the general solution is going to look like. I hope this is clear to all of you. I hope this is clear to all of you. So let's now take some questions. Okay. So please let me know if you have any questions. Hi Nitin, you are great. South se ho kya? No, I am from West Bengal. Okay. Nitin, I am from West Bengal. Okay. Samresh Saha, hi. Is this clear? सबको समझ में आ रहा है? क्या ये चीज सबको समझ में आ रहा है जो डिफरेंशिएशन में दिखाया? प्लीज लेट मी नो इफ द सॉल्यूशन स्टेप्स इज क्लियर और नॉट. क्या ये स्टेप सबको समझ में आता है? Please let me know in the live chat, is this clear? Or if you have any question, please let me know in the live chat so that I can take up any question, any queries, any doubts. Right? So I hope this is clear with all of you, right? Even if it is not clear, with solving some questions, I think it will be mostly be clear, okay? So we'll try to solve some question and we'll see that this is very simple, okay? And you will see that there are a lot of questions that has been asked in previous year JEE Mains and Advanced based on this particular types of questions, right? So you will see that these kinds of questions are really, really important. And if you try to understand only this part of the differential equation, I think you're going to score you're definitely going to score a lot of marks in, especially in the calculus portion, okay? Because generally, if you look at the JEE Advanced or JEE Mains types of question, in JEE Advanced, there will be application type question where they will give you a integral equation and they will ask you to try to get to the solution, or where the integral equation by doing some derivative or by doing some manipulation, it will be in form of some differential equation of first order linear differential equation type, right? And the solution of such equation is going to be very, very simple, right? This over here, right? I hope this is clear to all of you. I hope the solution step is clear to all of you. Okay. I hope this solution is clear to all of you. Please let me know in the live chat if you have any question, any queries. Okay. All right. So I'm going to a live chat. If you have any queries, please let me know. Otherwise, we shall proceed with solving some questions. Okay. All right. So let's try to see some example question to understand how we should go about solving this kinds of problem, right? And there is a certain algorithm to solve this question. Let's try to understand that in step by step, right? So let me take one question, very simple problem to start with, right? So the problem, so here it is mentioned to solve the following differential equation, that is given as dy by dx plus 2y is equals to cos of x, right? So dy by dx plus 2y is equals to cos of x is given as the following differential equation. So let's try to see how we can proceed with the solution of such differential equation. So if I look at the solution, of this differential equation, first of all, if we look at the solution, or the first of all, to identify the differential equation, it is simply a linear differential equation, right? So that is also a very important step to understand that whether it is a linear differential equation or not. So it is a linear differential equation of first order and first degree, right? So it is a linear differential equation of first order and first degree, right? So once we identify this particular thing, that it is a linear differential equation of first order and first degree, our next task over here is to understand how to solve this differential equation, right? Now we have already seen in our previous understanding that in order to solve this differential equation, we need to multiply both the side with a integrating factor, right? So here, if I try to find that integrating factor, so what we have seen that our integrating factor or integration factor is basically, so if I have the differential equation like this form, that is over here, so our integration factor becomes e to the power, integration of p dx, becomes simply equal to integration of, sorry, e to the power integration of p dx, right? So if I do that over here, my p term is basically going to be equal to, simply equal to a constant, that is 2. So that will be e to the power integration of 2 dx, and if I just integrate that, it is going to be e to the power 2x, e to the power 2x, right? Now the general solution, now we know the general solution is basically, we already seen the derivation in the previous steps. So the general solution is going to look like y into integrating factor is equals to integration of q into integrating factor dx, right? That is going to be the general solution. And then if I proceed with the general solution over here, my general solution is going to look like y into e to the power 2x is equals to integration of cos x into e to the power 2x, right? Now this is going to be the integration over here. So I just need to carry out this particular integration on the right hand side in order to get to the solution. Now we have already seen the integration of this kind of form by using, simply by using by parts, okay? So we can solve this integration by parts, right? So we can solve this integration by parts, and you can see and you know the solution. And I already mentioned about remembering the formula for the solution. It is very simple. It is basically equal to e to the power 2x, that is e to the power ax plus divided by a square plus b square into a times of cos x minus b times of sin x. That was the solution, right? So over here, so a is 2 over here and b is 1 over here. So 4 plus 2 squared plus 1 square is equal to 5, right? So e to the power 2x by 5 into multiplied with 2 times of cos x plus sin x over here, and then I will have some constant plus c, and that is going to be the general solution. So this is how the general solution of this differential equation or is going to look like, which is basically a representing a family of curve, right? So please try to solve this by using by parts, then you will be able to get to this solution over here, okay? So please try to see whether you are getting the solution or not. Please let me know in the live chat, are you getting the solution or not? Are you able to get to the solution over here? All right. Is this clear to all of you? Is this question clear? Is the solution clear? Did you able to understand the algorithm, the planning behind how to solve such differential equations? If you have any question, please let me know in the live chat so that we can discuss about it and you actually don't have any doubts or questions, okay? Let's discuss about, if you have any questions, we can discuss about it, or let's proceed with our next problem, right? So let's proceed with the next problem. I hope the question is clear. I hope this question is clear to all of you. So let's try to see our next problem. Now, please try to solve this problem. Okay, I won't solve this problem directly, but first of all, please try to solve this problem so that we can discuss about the solution. Okay. Okay, please try to solve this problem. Okay, again, a very simple linear differential equation, right? So please try to solve this problem with base E over here. Okay. So please try to solve this differential equation. Okay. Try to solve this differential equation by using the understanding what we have developed about the previous discussions. All right. So please try to solve this problem. Please try to solve this problem. Please try to solve this problem. If you have any question, please let me know in the live chat right now. If you have any question, please let me know in the live chat right now so that we can discuss about it. Okay, please try to solve this problem. I hope this question is visible to all of you. Please try to solve this problem so that we can discuss about the solution. Okay. If you have any question, we can discuss about it, but please try to solve this problem. We will discuss about lot of questions, okay? So be quick enough so that we can take up some more questions to understand any more general types of solutions, right? And then we shall proceed with discussion about the Bernoulli's differential equation, right? The Bernoulli equation, okay? So that is another special type of differential equation or linear differential equation that is known as the Bernoulli's equation, okay? So we'll try to see about that particular equation and then we'll move up to discussion about the orthogonal trajectory, okay? So there are certain things that we need to discuss in this class itself. So please try to solve this problem so that we can proceed with discussion about those types of differential equation, right? And at the end, we shall take out the exact differential equation, right? Certain cases, the difference derivative term is an exact derivative, right? So in those kinds of differentiation, let's also try to understand how to solve an exact differential equation form, right? So we'll go to that particular part, but please try to solve this question so that we can take up the other parts as well, right? And then after that, we are going to end at this particular chapter and we're going to solve a lot of questions, lot of sample examples, problems, lot of questions, especially questions from the previous year JEE Mains and Advanced problems, okay? And we also try to see which of our equations are basically solvable and which of the following are not solvable, right? And we'll see how to generalize application types of problems, right? So in generally in JEE Advanced, there's going to be a lot of application types problems, right? And especially if you have studied chemical kinetics, you must have came across rate equations, right? For example, like I'm just giving a simple example, right? Right? In first order chemical kinetics, you must have seen these kinds of equation, right? Like this form of differential equation, right? So these kinds of differential equation or first order differential equation, right? So or maybe like in any other rate equations or kinetics equation, you must have came across a lot of differential equation, right? So this particular chapter is basically going to teach you how to come with the or how to approach any general solution of such differential equation, right? So please try to proceed with the solution so that we can discuss about the solutions, okay? All those particular question as well, right? So we are going to discuss a lot of example questions, lot of numerical problems as well, especially from the previous year problems as well, right? So that you are ready for the actual examination, okay? All right. So if you look at this problem over here, again, looking at this problem or the differential equation, you can easily judge that it is a linear differential equation of first order, right? So it is a linear differential equation of first order and Ronak, for JEE 2026. Yes, these contents are basically for JEE 2026. Okay. So whoever is going to attempt the JEE in this January attempt as well as in the April attempt for this year, they are definitely going to for the next year, that is 2026, right? Or in this particular session. Okay. They are definitely going to follow this particular contents. Okay. Ronak Tegi, I hope this is clear, right? And if you want to get more generalized discussion on live one-to-one clearance or doubt clearance, you can definitely contact us on the number that is given on the live chat as well as in the description box of this particular live session. Okay. So with this, let's try to see the solution. So again, it's a linear differential equation. So if I try to find out the integrating factor, which is again e to the power integration of 1 upon x dx. So this is going to turn out as e to the power natural log of x and which is equals to x, right? Which is the base changing formula. So this is basically by the base changing formula I got x, right? So therefore, my general solution from here will look like y into integrating factor that is equal to x is equal to integration of log x into x dx, right? Log x into x into dx, right? And then my solution is going to look like, the general solution is x into y is equal to, so this is going to be by parts, so I'm just applying the by parts over here, minus integration of x square by 2 into 1 upon x dx. So that is going to come out as, plus some constant c, which is going to come out as x square by 2 into natural log of x minus x square by 4 plus of c is equals to xy. So this is going to be the general solution. This is going to be the general solution of the differential equation that you see over here, right? So this is how the general solution of such differential equation is going to look like. I hope this is clear to all of you. Did you get this answer? Did you all get the same answer to this question? Did you all get this answer? Please let me know in the live chat. Are you able to get to this answer or not? Are you all able to get to this answer or not? Please let me know in the live chat. If you are able to solve this question, let's now move to the next problem then. Okay. Okay. So let's try to move to the next problem. Now this is going to be an interesting problem. Okay. This question is going to be interesting. So let's try to see the question again. Solve the following differential equation that is given as dy upon dx is equals to y upon 2y natural log of y plus y minus x. Okay. So looking at this problem, it might not look as a first order linear differential equation, but by changing the order of derivative, okay, by changing the dependent and independent variable, or by playing with the algebra, you can get to the linear differential equation of first order. Okay. So please try to solve this problem. Please try to solve this problem. I give you some time to think over it because it's a very nice problem. Okay. So please take your time to think over this problem. This is really a nice question. Okay. This is really a nice question. Please try to think over it so that you can try to see how you can change the variable so that you can get to the solution step. Okay. Okay. So if you have any questions in the previous example or any discussion, please let me know. Please let me know if you have any questions. If you have any question, please let me know so that we can discuss about this solution. Okay. Also, if you have any doubts, you can let me know. If you have any question, we can discuss about it. Please let me know in the live chat. Also, please try to see how we can proceed with the solution of this problem. Okay. This is a really nice problem. If you have any ideas, you can let me know. All right. So if we look at this problem, because this is a really nice problem, so I'm not going to discuss this in bit detail. So if you look at this problem, the equation, looking at this particular form of equation, you might not think that this is a linear differential equation, right? what if I ask you to take a reciprocal of it, right? What do you actually mean by reciprocal or taking reciprocal? That I am going to change the order of the derivative, right? So with respect to x, I'm differentiating it, but now I'm going to differentiate with respect to y, right? So I'm going to change the order of derivative, and then this equation can also be written as 2y natural log of y plus y minus x and whole divided by y, right? Right. So then I can write this equation as 2 ln y, sorry, 2 natural ln of y plus 1 minus x upon y. So the interesting catch over here is that my differential equation is now changed in a different variable such that it becomes a linear differential equation, right? So now the differential equation is basically like this, which is a linear differential equation over here, that is dx upon dy plus x upon y is equals to 2 natural log of y plus of 1. Now this is again a linear differential equation. So from here I am going to find the integrating factor. So the integrating factor is equals to e to the power integration of, now instead of x it will be with respect to y now over here, because our independent variable becomes y over here, right? So this is going to equals to e to the power integration of 1 upon y dy, which is going to be e to the power ln y, which is equal to y. Now if I just solve this, the general solution, so the general solution is going to look like x into y is equals to integration of 2 natural log of y plus 1 into y over here and then dy, right? So if I just try to solve this problem over here, and if I just finally write the solution is going to look like x equals to y natural log of y plus c upon y, right? So this is going to be the general solution of such differential equation, or the family of curves that is satisfying the following differential equation, right? So I hope you can check the solution, that this is clear, right? If you have any question, please let me in the live chat so that we can discuss. Lucky 7 waiting only. You have any questions, any queries to discuss about, so that we can discuss and talk about in this live class, right? So this is going to be a general solution, is how it's going to look like, right? I hope this is clear to all of you. I hope this is clear to all of you. I hope this solution is clear to all of you. So please note that not always that you will have a differential equation will be of first order linear differential equation in x, right? Whereas it might also be happening like where you have the independent variable as y. So you have to note that instead of doing the integration in x, you have to also perform the integration in y, depending upon which of the following is the independent variable, right? So that is the important catch over here. I hope you are able to catch up this particular thing. So if this particular part is clear, let's now move to some of the problems so that you can try to practice up in the homework, right? So some of the homework problems that I'm trying to give you over here. So please try to solve this question as homework problems, right? So the homework problems are, so please try to solve this differential equation that we have cos square x into dy by dx minus y tan of 2x is equals to cos to the power 4x, right? Cos to the power 4x, right? And please try to find a general solution such that my y, when my x is equals to pi upon 6, is equals to 3 root 3 by 8, and please note that mod of y x is basically less than pi upon 4. Okay, so with having this condition, please try to find out the general solution, or please try to find out the particular solution. Okay, so in this case you won't be getting the general solution, you will be getting the particular solution, all right, which is a particular equation of a curve, right, which is satisfying this boundary condition or initial condition. Okay, all right, so this condition should be satisfied by that particular curve so that you can get to the constant value, right? So please try to solve this first problem. And another problem is like this. So second homework problem, please try to solve this differential equation, that is dy upon dx is equals to y phi dash of x is equals to phi of x is equals to phi of x into phi dash of x. Okay, please try to solve this problem where phi is a any given function. Okay, phi is a given function. Okay, please try to solve this problem. Okay, please try to solve this differential equation. So these are the two homework problems. So please try to see the solution of these two homework problems and let me know the answers in the comment section. Okay, good. Devansh Joshi, very good. Please take a screenshot of these homework problems and please solve these problems, and we will try to see the solution of these questions in our next class. Okay, so our next class is going to happen again tomorrow, where we're going to discuss about the Bernoulli equation and the orthogonal trajectory. And with this, we are going to move into our next topic of differential equation, that is exact differential equation. And with this, we are going to take up some problems to practice, and with this, we'll be done with our entire journey of the calculus sessions. Okay, so we started with functions and we are ending at differential equation, right? So with this, our next topic is definitely going to be on vectors and 3D geometry. So I hope you are excited for the next topic, and we're going to come live again tomorrow. So if you're into this particular channel, please subscribe to the channel and hit the bell icon so that you don't miss out any notification, that whenever we are live, you get a notification and you can attend the class live and you can get your doubt cleared by these faculties, by this important and of any important concepts on any important questions that you are having by the renowned faculties who are here, right? And if you are interested to join up the one-to-one discussion and live classes, you can always contact us on this particular number that is given over here in the description box, as well as I'm writing the number over here. So if you're interested in taking up any live classes or online classes, please contact us on this number 833-9827-528. Okay, so please contact us or give us a missed call on this particular number to get access to our paid classes. Okay, or you want to clear your doubts or you want to have your mentorship sessions, please you can contact on this number. Not only for maths, you can get mentorship for physics, chemistry and biology, right? So with this, I would conclude the session over here. Thank you for your attention, and let's meet again tomorrow. In tomorrow's session, we're going to discuss about the Bernoulli equation and orthogonal trajectory. Thank you for your attention, and I wish you all the best. So please try to solve these two homework problems, and then we